Hi, I'm Nancy Wilkins-Diehr from the San Diego Supercomputer Center. I'm the Associate Director for Scientific Computing here, and the Supercomputer Center is one of a handful of organizations funded by the National Science Foundation in order to advance science and engineering in the United States. So the idea behind these centers is to provide very large-scale resources that are unavailable to scientists at their local universities. We have large shared facilities that are available at no cost to the nation's researchers. We support users from a variety of disciplines, biology and chemistry and psychology and computational fluids. Users tend to be very sophisticated computational scientists. By the time they're reaching a very large center like ours, they've been programming for years and using departmental-sized clusters and are very familiar with parallel programming. The mission of the San Diego Supercomputer Center is to use technology to advance science. And we're better able to advance science if we're able to provide our researchers with tools that allow them to use our resources effectively. So with not a lot of time investment, with not a lot of programming investment, that allows them to focus on the science, keep the creativity, keep the flow of their work without getting distracted by details of high-performance computing. I like to liken this to the use of something like Microsoft Word. You just want to use it to get your work done. You don't really want to understand a lot about the ins and outs of it. And with StarP, the users are really able to do that. They're able to focus on their algorithmic development, and with just small changes in the way the arrays are described, all of a sudden routines are parallelized and they're able to make great gains without a lot of investment. Currently in the supercomputing industry, we see the scale of machines growing very, very rapidly. So the challenges that computational scientists will face is that all of a sudden they're using tens of thousands of processors rather than hundreds of processors. So fault tolerance becomes an issue, message passing becomes an issue. The very advanced computational science groups are able to deal with these rapid changes and make the investments to take advantage of them, but a lot of people are not, and a lot of new communities are not. And this is a particular focus for some of the NSF centers. We want to make sure that cyber infrastructure that we're deploying isn't leaving anybody behind. With the advent of more powerful desktop systems, we've seen a lot of computational scientists who've been able to do the work on their own desktop platforms rather than spend the years of investment required to use a real supercomputer center. So with StarP, we find that bridge is much easier to cross. We find researchers able to design problems on their desktop, make use of a very powerful back-end system without having to understand how to program an MPI and all the very complex investment in rewriting codes. So it's been very exciting for us to be able to offer StarP to our current researchers at the San Diego Supercomputer Center. The look on their faces when they realize that they're able to accomplish an analysis in 2 days that previously would have taken 200 days is very powerful. When you're used to working in a particular box, there are certain sets of problems that you'll even consider attacking. When all of a sudden you're put in a much different box, you know, your mind really opens to what else you might consider. One of the goals of a center like the San Diego Supercomputer Center is always to reach new communities, to be able to expand the impact of high-performance computing resources. One of the primary benefits with something like StarP is that users have to do very little to be able to take advantage of more powerful resources. I would say one of the benefits of StarP is this ability to attract new user communities and to have people be comfortable with a familiar environment and all of a sudden be able to take advantage of much more powerful resources, really with sort of no limits. Before we had StarP, we really lost a lot of users, users who were not able to make the investments necessary to run on a very high-performance machine. When the compilers aren't there, when the post-processing isn't there that allows users to very easily take advantage of high-performance resources, eventually researchers are content with doing things on their desktop, even if it's not what they really want to do. So the ability to change that thinking is very powerful and something that we've not been able to do in recent years. We've been very pleased with our interactions with STAR-P. We found excellent support from the STAR-P team, excellent training mechanisms, and I think really we found ease of use reported by our users. I think that's what's been most compelling to us, is their interest in the product and their communication with us that it meets their needs so effectively. If the United States is to remain at the forefront of science and engineering, it's very important that we offer our nation's researchers access to these high-performance computing resources. The advantages of a package like STAR-P in a university environment is it really enables us to prepare tomorrow's leaders for tomorrow's technology.